90% of everything that is contaminant right now is either Listeria, E. coli, or Salmonella. Our objectives are that when we finally have our product out in the world, we can literally save thousands of lives per year and millions and millions in healthcare costs. All bacteria species are different. The wavelength of the laser that we use, wavelength meaning the up and down period, the wavelength is the same size basically as your family of bacteria and other things. And the other part about it is the laser penetrates the bacteria. So when we flash the laser beam on a bacteria as it goes through our system, we're able to measure both the outside and the internal characteristic of a bacteria one at a time. And the way the thing works is a series of arcs. You've got a laser beam that goes into our vial, and you have a thing called light scattering, which is emitted from the bacteria sample. And what we do is we measure hundreds of thousands of the same family of bacteria so that we really come up with identifiers. David, how many tests did they run for the accuracy part? Do you remember off the top of your head?
We did many hundreds,
yeah.
many hundreds of tests.
And we ended up in the high 90s for accuracy. Unbelievably simple to use, as long as you have good regimen taking your samples and then follow the procedures. We feel that a bright college-age student, maybe just a high school graduate even, can be well trained on this system with the laboratory procedures, probably in 2 or 3 days. You agree with that, Dave? Yeah. And probably be bored on the 3rd day.
Right. Identification begins with culture plate and individual colonies on the plate, as you see here. First, you take a loop and scrape one colony off the plate. And then you put it into a microcentrifuge tube that has filtered water in it. Spin it around to dislodge the material into the water. You close the microcentrifuge tube, then you vortex the sample for 15 to 20 seconds. This breaks the colony into individual cells. And now you pipette approximately 1 microliter into the sample vial. You put the parafilm back down, hold it in place with a rubber band, and lift the corners of the parafilm up and away from the sample vial. And then you proceed to the system. Now you put the sample into the system. Put the cover on and start the identification process. Now you click the Identify button, enter information that describes your sample, and click OK. The system is now attempting to identify the bacteria. The logo in the upper right-hand corner flashes red every time the system detects an individual bacterial cell. The progress bar in the center gives an indication of how far along the identification process you are. And the gauge in the lower right-hand side gives a rough idea of the concentration of bacterial cells in the sample vial. All right? So at this time, the system has identified the sample as listeria, which in fact it is.
Average test cost right now, and you could add overheads and all kinds of this stuff, but we try to keep apples to apples, is somewhere in the neighborhood of $25, $30 versus 5 cents, 10 cents. How many failures have we had in the lab with systems over the 6 years that I've been here, do you think?
I've had maybe 2 power supply boards go bad and 1 laser.
So the question was, if you wanted to hook it into your laptop, David had some little teeny computers out in back.
A little netbook.
You know,
It wasn't the current generation either. It was like the previous generation netbook that ran the device. Same program that you saw running the same kind of test.
Wow.
So you could use a netbook, $200 netbook, or you could use 3 or 4 times that pad of some kind if you wanted to run it.
The new system is 100% USB compliant, meaning literally you can plug it into doggone any computer. It's being manufactured for us by OSI Systems up in Hawthorne, a world-class manufacturing company. Everyone that's looked at the system from a technical point of view has been pretty well blown away, including OSI. That's why they're building it for us. OSI has already given David some really good thoughts on what they call the MIT 1500 right now. So I mean, we're already looking, that far ahead. But the nice part, always to remember, is when we're going after a new bug, or we're looking at 3 bugs, or anything that I could envision us doing over the next 3 years, 4 years. There's no change to what we're going to do with the optical unit. Might be some changes with the software, might be some changes with the user interface, things like that. But there's an awful lot we got to learn in the user market too, because nothing like this has ever been out there before. I'm pretty convinced that the way this thing should go after we start getting multiple systems out is through us providing the servers and letting the machine dial up and get online as soon as you make a request. And that provides us so much more control over the whole product. The interesting part about the identification of anything in the bacteria range, whether it's fungi or what have you, there's an awful lot of more applications that we can expand it to. Clinical, like with MRSA, a lot of other things down the road. But by far the largest market segment, which in the U.S. is about $3.5 billion a year just in testing. $3.5 billion just in testing in the U.S. is food safety.